Hello everyone and welcome again to the SQL course. Okay, so we've learned how to combine tables with joins. We've seen some examples of the inner, left and right joins, and also how we can combine using multiple keys. So most of the use cases using joins are done to combine tables horizontally. So we want to add more columns to our specific table. Of course, there are other usages for joins, but most of the times, at least 90-95% of the times, that's the main usage. But what if we have two tables with exactly the same structure, or at least with fields that we want to use from a similar structure and combine them into a single table? In this case, stack one table on top of the other. That's where we use the union operators, something that we are going to learn here in this lecture. So I'm going to use this for-union operator. This is going to be the script that we are going to use. I'm going to open up, of course, a new SQL file so that we can write from scratch. Okay, so for example, let me pick up this code that creates two different tables, and you can pick it up from the script that's on the course materials. So as you see here, we have two different tables that contain store1 and store2. Now, store1, this is a brick and mortar store that sells products regarding pets, either food or toys or whatever. And here we have these columns that are the invoice ID. In this case, each store will have their invoices, the sales that they do, the customer ID, the item quantity, so how many of those products were taken by the customer, the order value, so how much did it cost, and also the product name. Here in the store 2, we have this for a single store, for store 1, where we are going to have many invoices for this specific store. But then we have this also another table called store 2 that contains exactly the same information but for another store. And the system where this database was set up was a bit older. The customer ID or a loyalty card wasn't implemented. So there isn't a customer ID on this table. This means that the structure of both tables only differs on the customer ID. But of course, they all contain invoices from different tables. How can we append these data one on top of the other, even though they have a slight different structure? Let's create both of these tables and insert some invoices. Don't forget, of course, to connect to your local server. Okay, so running this one, this should create both tables and we'll have the data from both stores. Let's also take a quick look at both of these tables. I'm not coding these create tables and insert into instructions because they would take a lot of the time of the lecture, and we've learned them, so it would take a bit of time from our lecture where we would basically see the same type of instruction. But if you want, on your own, you can code them by yourself, looking at the course materials, seeing the structure, and then trying to code the instruction all by yourself so that you can also train this skill a bit more. So let's look at our store, and there you go. We have three invoices with IDs 123, 165, 166. So they are basically dog and cat food orders, or in this case purchases from customers. We have different customer IDs. In this case, each of these orders has a customer ID, so they are known customers by the store. And if we go to store 2, as I said, and imagining and role-playing here a bit, the system was a bit older, so there's no customer ID, there's no way to know which customer purchased that, we only know the invoice. Now, I would like, for example, if I'm doing a report where I want to check the total amount of sales from both stores in my company, or in this case in this pet, toy and food company, I would like to join both stores. Of course, I would like to have an easy way to combine the sales from both stores. So what I can do to have this in a single table is a simple union operator. So the union operator is really easy. We just learned how we can do selects. So I'm going to do a select of these columns. For example, I'll want the invoice ID, the quantity, order value, and product. Why am I only selecting these columns? Because these are the ones that are common between the structure of the two tables. We'll check also what will happen when we don't do that. And now I'm going to do from sandbox.store1. So if I run this, this should be what we are already familiar, select from our simple statement. Now a cool thing is that I can remove the end of my query and do union. Now the union will be an operator that will combine this query that we have right here with another query that we want, and in this case I'm going to do a select here for store 2. Exactly the same select, but for the store 2. Now to do this union, we need to have exactly the same columns, or at least we need, for that to make sense, we need to do that. We'll see what will happen when we don't. Now I can close the query because of course this is a single query statement if you use the union, run this one, and there you go. As you can see, we have the 3 orders from store 1, 2 orders from store 2, exactly in the same table. This is the same result. And this is super cool because now I can use this information or do something called subqueries using this information. That will be something that we'll learn a bit ahead in subsequent sections. But now I have a single table with this information. So I have a single table with the invoices from both stores, and I can compute stuff on top of this. Now, you might be asking what happens if I try, for example, to put the customer ID here in the select. If I just put it on the top side and I run this, I'll have a mistake. Why? Because the select statements in the union have a different number of columns. I can't do that. When I'm doing a union between both tables, the selects must have exactly the same number of columns and also the same type. If I try to put the customer ID here coming from store 2, you'll see that this will of course give me an error because there's no customer ID in that table. Now let me remove this one and do it all the same. Now, for example, we are not tied only to this union. There's a significant difference that I would like to tell you. There's the union and there's the union all. So here, union or union all will not make any difference because we have distinct rows, meaning that there's no duplicate rows between our tables. If there is a duplicate row between our table, then in that case, the union all will retain the duplicates and the union will not retain the duplicates. Will basically collapse those duplicates into a single result. We can do an exercise to see that. And for example, I don't need to have all these columns if I don't want to. A union can be on only a single column. For example, I may only want this column by doing select the product from the store 1 and the store 2. And I'm going to now do an union all. The union all, again, will show these 5 values. Right now, this also shows the 5 invoices, and union all do not make a difference because these rows are distinct. They have different values. For example, the invoice ID is always different. But if I do this here with the product store, oops, I have here a small typo, sorry about that. Let me run this. Okay, I have dog food, which is the first invoice product, cat food, dog food, cat toy, and cat food. These are the products in each of the invoices. But I'll notice if I do a union on this, instead of the union all, I'll have only dog food, cat toy. So these are the distinct values for this product alone. Because I'm appending only the products of the first table with the products of the second table, and I'm not selecting more columns. If I put here all the columns, again, let me repeat that. If I put here all the columns, now this will not happen because the row itself is distinct with the union, because the invoice IDs are always different. If I had exactly the same invoice ID, item quantity, order value, product in both of the tables, in the result we would only have one with union. If we have union all, we would have the 2. Okay, just make sure you are aware of that. Now you can try here with several columns, for example, putting more columns, taking out columns, and seeing the behavior of union and union all. This is commonly called a set operation here in SQL. There are also other set operations that are unfortunately not available in MySQL, which are except and intercept. You can check on the internet what they do because I believe that it will be easy to understand now that we've understood union, but unfortunately those operators are not implemented in MySQL. You have to do some workarounds to get there, and I think that is not a priority at the moment because they're also not that commonly used in most use cases. Okay, so we finished this combining tables section. I hope this was clear to you. You've enjoyed this section. Now let's go to the quiz and case study that I've prepared for you. After that, you'll be ready for most things here in SQL, and you'll be ready to tackle more advanced problems using this language that helps you to manipulate data. So let's go to the case study, and I hope you're enjoying this course. I'll see you in the next lecture.